Hi, we're back again today. We're going to look at Y-branch fitting, a round Y-branch. Now, one of our more advanced fittings that we have, we've got an example one here. So we're streaming, we're going from a large end splitting off to two. In our case, two. We can have multiple though. We could go 3, 4, 5, whatever we want. But that one would take a different process. When we look at the two-way Y-branch, it's simplified compared to 3 or 4-way. Now we're going to work one pattern, one side at a time, which would be, if it was uniform or symmetrical, a repeat, you would just trace that pattern. If not, you'd have to develop the second side independently. We can't do it all at once. So if we had 2 different sizes here and so 3 different sizes altogether, we would have to do those 2 sides independently of each other. So we're going to work on that one. A more advanced look at that one is going to squared around on one side. So it'll be the same techniques we use in this one. We'd have a few changes to our element lines because we're not going to zigzag in the squared around like we will in the round, but just to give you an idea of what you can make with this same process. Okay, so squared around two-way Y-branch. So let's talk about a few rules that we have with Y-branches. First off, we have what's called our crotch height here, and the crotch height always needs to be a certain height compared to the base to keep the fitting and airflow happy. So if we have a size here, and let's just put 8-inch diameter at the base there, our crotch height here would have to be a minimum of 3/4 of that diameter. So in this case, we would be a 6-inch crotch height to make up the 3/4. We can also call that 1.5 times the radius. It would give us the same number. So if we did 4 times 1.5, we would still get 6. So the base here has to be 3/4, not 3/8, 3/4 of the diameter, or 1.5 times the radius. So that's our first rule. So when you get a drawing or something, somebody's giving you a sketch, a shop drawing, make sure that we're following those rules. The second rule that we want to follow always is we have to consider, because this fitting isn't designed to recuperate airspeed if we've lost CFM somewhere. So it's not a reducer. It's merely to split airflow into 2. So that means that whatever we put in has to come out, and it has to be equalized. And we can do that by area. So we could say that the area of the 8 has to equal the sum of the 2 ends. Okay, I mean, it's as simple as that. And what it comes down to is the CFM going in has to equal the CFM coming out of the 2 ends. Okay, and an easy way we can do that is by Pythagoras. A squared, b squared, this becomes c squared. So if you're trying to size, you're not sure how big the ends need to be, we can use Pythagoras in a reverse way to accommodate that. But we should always double check a fitting to make sure that it does size correctly. Okay, so let's get started. Let me scrub off some of these rules that we're talking about, and we'll put some sizes to our shop drawing here. Now let's go 7-inch diameter at the base here, and we'll go a 5-inch on the ends. And ours will be symmetrical, so 5 on both sides. So coming in at 7, leaving at 5. Okay, that gives us 5 1/4 for our crotch height here, and we're also going to run a center line up right here that will establish, it'll give us the length of this fitting here. So let's go 7 inches on that one. And we'll run ours at 60 degrees. Okay? So again, we're gonna start out, we're gonna develop one side at a time, so we want to draw a full elevation view of this end. Okay, and we'll get all our profiles and element lines on there as well. Okay, so 7 to 5. And we'll start with that elevation view. So I started out here. This point right here is this one, center of the base, and I've drawn my 3.5 inches, and I've drawn my 60 degrees up. Perpendicular to that, I drew my 5 inches out here. Okay, and now I can go in. I can establish my crotch height, and then join the top to the bottom. Okay, so elevation view there. We're going to continue with that. We're going to go to profile everything, but a few differences. Profile up top, it's pretty standard, just like we've done before. It's just a round, but we need to have what's called a sector on the inside here at the crotch, and we're going to use a half profile down here. Okay, the difference between a profile, which is down here or up here, and a sector is the sector's inside of a part. Okay, so we want to see the shape of this crotch here and how that's coming around compared to with the height and the depth of that thought about. And so if it's inside of a part, it's a sector. If it's on the outside, it's a profile. So let's go ahead and profile and sector that unit there. Okay, you can see here that I've got started. I've got my 2 profiles done. I've brought this one all the way across, and I'm going to use this one to create my sector inside here. If we think of the 7-inch base compared to the crotch height, you can see that this is longer than this one. So the crotch height as a radius is taller than the base as a radius. And if we look at that fitting, okay, you can imagine that if we're dealing with a height of the crotch and the depth of the base, and those two are different, we're going to end up with not a round shape there, but an elliptical shape. It's going to be stretched out in this crotch area here, okay, because we know the width of it is at the 7. But we know the height is at what we've established as crotch height to keep airflow correct. So that's going to be an elliptical shape. So that's our next step, is to create that. Okay, so the way I'm going to create my elliptical shape is going in with the 2 different radii. So I'm going to set up to this crotch height here and swing this one around. And let's bring that through here. And then divide that one. Just like that. So I have my profile, the part of a profile here, part of a profile here. And I know that the crotch can't get any wider than the base here. That's as far as it can go. So when I go to draw that in, I know that it can't get wider than here, so I'm gonna put a little tick there, and then I'm gonna run these lines vertically. Okay, and I'll run the crotch height lines horizontally. And that creates our ellipse. We have a point here, point here. And you can see it comes from where we set it in maximum width here, and then slowly tapers, but it's stretched upwards, okay, because of that crotch height there. So now we have our ellipse, we have our sector. So this one is our sector view here. Okay, just for clarity, just so we have it, I'm gonna get off these lines here because I don't want those on there anymore to add more that we don't need on there. When I get to it, we're going to use difference in profile for this fitting. And when I'm using difference in profile, I'm using this line here now. Okay, those are my profile heights now. Okay, so I'm going to use just as normal these ones in here. But when I come down this crotch area here, I'm using these ones. And these points here are my step-offs. Okay, so once I get labeling on there, you can see that they're all different. This one's the longest, that one's the shortest. Okay, at particular points on our pattern, we need to make sure that we grab the correct step-off. Okay, so next step, I like to label mine next, and then my labeling can help me establish all my element lines to where I'm zigzagging back and forth here. Because this one, it's done just like around now. Once we get labeling on there, get a vertical starting point, and use difference of profile. So let's start off, let's go 1 here, 2 here. Okay, so that gets us odd on the top. And even at the bottom. Now, remember we use this just for creating our ellipse. We're not actually using it for any development of the pattern. So here's point 8 here, but look at where it references. Is right here. Okay, so that means this is point 8 as well. And if we pick up, we know that that's our radius, that's 3.5. So is that one. Remember, because we said that the width had to match that. Okay, so those lines are identical. It doesn't matter which one we use. But we have to see that they reference that one point. Okay? 8, 10, 12, 14. Okay, we'll fill in all our element lines now. Okay, so we have a completed elevation view now. We've got all our element lines in place. We have our profiles, and we have our sector, we have our labeling. We have everything we need now to establish our pattern. So let's go ahead. I'm going to scrub that shop drawing off, and I'm going to start with vertical line 1, 2, which just like our round to round is a true length in the elevation view here. Okay, so now we're just going to follow our number line. 1, 2, 3 is next, of course. So 2 to 3, 0, and this a lot of the rules that we've had before, or methods we've seen before. No profile at 2, full profile at 3. So I'm going to bring the line 2, 3 up to this line here to do my comparison. Okay, so there's the length of my line from this point, from profile 3 all the way out. I grab the true length and swing it from 2. Grab step off 1, 3 and swing it from 1. Okay, 3, 4. If I look at my drawing, 3 and 4, profile 3 is the smaller one. So I'm going to bring it down to 4. From the outside, again, leaving the difference in the corner here. Pick up length of line 3, 4, and bring it down to the base. Okay, so there's my length, there's my difference. True length, 3, 4. Step off. For 0.4. Okay, and we're just going to keep using that process back and forth. 4, 5. 5 is the bigger of the profiles. Okay, so we've made it around to our crotch here now, and this is where the pattern is going to have a real change to it. Because if we kept going like the round to round, it would stay consistent and keep swooping down here. But we have a really drastic change here. Okay, we're going 90 degrees, so our pattern is going to do some 90-degree change and start going the other way. So we can expect that from what we see in the elevation view. Okay, so let's keep going. So again, using my 10 from our elliptical shape here, coming inwards from there. My difference is here. And I'll grab the length of the line and rotate it 90 degrees to that difference. Pick up the true length. There we go. So you can see where we've got a real change there. Step off, 8, 10. This is a pretty big step off. (12, 13). Full profile at 12, nothing at 13. So we're taking the full distance. I grab the line, rotate it down, and come right from the profile line out. And our last line, true length in the elevation view with no profile compared to no profile, tells us it's true length. 13, 14. Let's get that out of there. And the last step off. Okay, so what we can see is we stayed nice and consistent up top here. We have a little bit of a rise at about 0.3 here. It comes down and goes up and then back down again. That's okay, remember, as long as it's not a big lump somewhere. But a smooth, consistent arc is what we're looking for there. But even though we made this drastic change at the bottom, our top stayed consistent. So that probably tells us we're on the right track, that we've completed this correctly. So let's fill in our line work here and see how our pattern looks. Looks pretty good. Okay, two-way Y branch.